Sorry there. Oh, itchy beard. So today we're talking about dissolving, and we're going to use a classic example of salt and water. Water is your solvent, salt is your solute. The salt can dissolve into water, meaning that it is soluble. When it dissolves into water, you have what we call a solution. Let's see what happens. Now, first of all, I want to just talk you through salt. Solid, it's an ionic compound. What does that mean? Ionic compounds are compounds that are made of ions. An ion is a charged particle. Now, salt is sodium chloride, NaCl. It's an ionic compound, and what that means is that electrons have been exchanged. Sodium has given an electron to chlorine, and they've bonded after that. Now, when sodium gives its electron to chlorine, the chlorine becomes a negative charged ion, negatively charged ion. And because sodium loses a negative charge, it becomes positive. So you have these positively charged sodium ions and negatively charged chlorine ions. Now, what do opposites do? They attract, boom, like that. That's an ionic lattice. Positive, negative, positive, negative, positive, blah, blah, blah. Okay? That's your salt there. Now, water is made up of oxygen and two hydrogens, covalently bonded together, no electron exchange, but because oxygen is big, it's a lot bigger than hydrogen, it's got a bigger nucleus, which means that there's a lot of protons in that nucleus. That positively charged nucleus is what we call, it creates an electrophilic element, which is oxygen. It's electrophilic, meaning that it loves electrons. Now, the oxygen pulls the electrons from the hydrogen, making the oxygen itself slightly negative. So what you get is you get this polar molecule, which is water. You get a negative oxygen and positive hydrogens. Now, these are important in how they help water to become a good solvent for salts. Because what's going to happen is the positive hydrogens are going to be a little bit attracted to our negatively charged chlorines, and our negative oxygens are going to be attracted to our positively charged sodiums. So let's start mixing, as you do when you mix water and salt or sugar. Let's start mixing them together. Now, I've got a positive hydrogen, it's going to go, oh yeah, give me a bit of that chlorine. And then, oh, negative oxygen is going to pull that away. So you can see that the water is getting in the way of the ions in the salt, and it's just pulling them away and getting in between them. Now, they're not chemically bonding to each other, they're just becoming attracted to each other for a bit. And that is what is going to give us our solution. So our water's there, so positive, positive sodium, negative oxygen there. It's just going to get in there. Oh, that's going to pull that away. Oh yeah, give me some of that. And then that's in there like that. Lovely, lovely. And so essentially what you get, guys, is you get this solution. Your salt becomes dispersed throughout the water, and you can't see it anymore. You can't see it anymore. Maybe it's a bit cloudy, but it's certainly not solid anymore. All right, so that's our water getting in the way because of those positive and negative charges. Now, you can physically separate them again. It's quite easily, so it's not a chemical reaction. Now, how do you separate them again? You evaporate the water off. You give it loads of energy, you heat it up, water molecules gain energy, and they just simply fly off, they evaporate, and they leave again. Now, as they leave again, as you heat them up, our positives and negatives can then be reattracted to each other, find each other again, like a magnet, you know, and form our salt again. Ping, 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 ping. That's it, gone, gone, gone. Now, what you may notice is that your salt is no longer like in a square block anymore, but that doesn't, because that's not how it's happened. But What you can note is that it's still a solid. Okay? And that is dissolving. I hope that's okay. Don't eat too much salt, it's bad for you. Boom.